This last graphing example, I still have an exponential function, y equals 1/2 to the x power. But in order to graph that, similar to the last example, I want to make a table. So my table, again, I'm going to select my values for x. I'm going to start with 0, 1, 2, 3, and 4. So for the first three examples that we've graphed for exponential functions, I selected the exact same input values. You can do that as well. But now I'm going to evaluate this function first when x equals 0. So I'm going to plug in 0 for x into the function, y equals 1/2 to the 0 power. If you do that on your calculator, you probably want to put the 1/2 in parentheses, and then remember this is your exponent button on your calculator. What you should get is 1. So when x is equal to 0, y is equal to 1. Then I'm going to substitute into the equation 1 for x. Y equals 1/2 to the first power. Is 1/2 or 0.5? It might be easier to actually write it as a decimal because that might be easier to graph in this case. Then you're going to substitute in 2 for your exponent. So it looks like this, y equals 1/2 squared, especially if you use your calculator. If you use your calculator for this 1/2 squared, unless you change your settings, it's going to give it to you in terms of a decimal, 1/4 or 0.25 when x is equal to 2. Then I'm going to substitute in 3 for x into this equation. Y is equal to 1/2 to the third power. So 1/2 to the third power is going to be 1/8 or 0.125 as a decimal. And then lastly, if I input 4 in for x into the equation, it would be y equals 1/2 to the fourth power. Again, if you're using a calculator, it'll give it to you in terms of a decimal, 0.0625. So I have probably enough points in order to be able to graph. I'm going to go by ones on my x-axis like I did on the last example. 0, 1, 2, 3, 4. This would be 5. Here's what I'm actually going to do. On my y-axis, I'm going to go by quarters. So this would be 0.125. This would be 0.25. Sorry, I said I'm going to go by quarters. I'm actually going by eighths here. This would be, so I'm going by eighths or 0.125. I didn't list out every single number, but I listed out enough numbers that we can graph each of the points. So 0, 1, right here. That's 8/8 or 1. 1 and then 0.5 would be right here. 2 and a quarter or 0.25. 3 and 0.125. Lastly, 4 and 0.0625 would be right here. Similar to our other graphs, even though I only went out to the 0.4 and 0.0625, the graph's going to keep continuing. What's actually going to happen is this graph would continue, get closer and closer to the x-axis and never touch it because it'll keep getting halfway closer every single time to the x-axis, but it actually will never touch the x-axis. I did want to make that graph continuous like I did and then make my arrow to the right. Kind of to summarize all the graphs that we just went over, we graphed exponential functions, y equals a times b to the x power. Here's one thing that you should have noticed. If b is more than 1, so this base right here, if it's more than 1, the sketchier graph would look roughly like this. It goes up from left to right. On the last example, even though we went over just one example where b is less than 1, like 1/2, here's what your graph would look like. Instead of going up from left to right, this is supposed to be my x-axis, this is my y-axis. Same on the last example. Your graph goes down from left to right. So those are the two types of graphs that you would get for your exponential functions.